Okay, so here we go with the Mod 10 group test. Let's see. Number 1 says graph the inverse of the graph defined by the given points and lines. So I see some points there. I see some lines. Before I graph this, actually, I'm going to come over here and answer this question. Okay, so is the original graph, meaning this one, a function? How do I check if this graph that I'm looking at is a function? Well, I use the vertical line test. And I see that if I draw a vertical line right there, it's going to touch this graph more than once. So what does that mean? No, it is not a function. It does not pass the vertical line test. Okay, is the inverse a function? Well, I can graph the inverse and then check the vertical line test on the inverse, or I can use the horizontal line test on this original graph. Does it pass the horizontal line test? It looks to me like it does, which means that when I graph the inverse is going to pass the vertical line test. Okay? So let's see. This looks like it passes. I'm going to say yes, because I can say one of two reasons. I can say the original graph passes the horizontal line test. And I think that's the easiest. I could say that it passes the vertical line test when I graph it, but I think it's easiest just to answer number 2 before I graph number 1. It gets a little more confusing when you have more than one thing on there at a time. So now I'm going to come back and graph number 1. How do I graph the inverse? Well, I take these and I just flip the points around. So negative 4, 0 is going to become 0, negative 4. Negative 2, 1 is going to become 1, negative 2. 3, negative 1 is going to become negative 1, 3. And 3, negative 3 is going to be negative 3, 3. Just flipping the x's and the y's. So let's see, 0, negative 4, that's the reflection of this point right there. 1, negative 2, so I can go ahead and connect that. That's the reflection of this part of that line, or of that graph. Negative 1, 3. Now we've got the crisscrossing there. By the way, when you're reflecting across a line, if you are crossing the line, you should intersect the original graph on that line. All intersecting parts should end up intersecting on that line, y equals x there. And then finally the last one, negative 3, 3. There's that part. And I can see that this part that I have graphed in pink, it does pass the vertical line test. And I knew it would because I used the horizontal line test on the original before I graphed this one. Okay, so the vertical line test works if you're looking at a graph. It tells you about that graph. The horizontal line test tells you about the inverse of the graph you're looking at, not the actual graph you're looking at, which is why I answered number 2 first. Okay, number 3 and 4 go together. Find the inverse of this line, and then I have to graph both of them. Now, before I find the inverse, I'm going to graph the original because I think it's easiest. So I'm going to start off with my y-intercept at 2, and then I'm going to use my 2 over 3 as rise over run. So from here I'm going to go up 2 over 3, up 2 over 3, and I'm going to draw in. Now it's easiest if you use a straight edge. Your ID card makes a perfect straight edge for the test. And I want to see that drawn in. Go ahead and put your arrows there. Go ahead and draw your line the entire size of the graph, so that way it's a nice, long, clear line. All right? Now I'm going to find the inverse, and I'll graph that. So let's see. Maybe I'll do this in a different color just to show. Okay, so finding the inverse, the first thing I do is I replace f of x with y. So y equals 2/3 x plus 2. Next thing I do is I need to get x by itself. So I'm going to subtract 2. So that gives me y minus 2 is equal to 2/3 x. Now, how do I get rid of the 2/3 if, you know, it's easier to get rid of 1/3 because I just multiply by 3, but how do I get rid of a 2/3? I have to multiply by the reciprocal. And the reciprocal is 3/2. Now, I have to multiply this entire side also by 3/2. So when I distribute this 3/2 here, I'm going to have 3/2 y minus, and then what I have to do here, let's see, let me do it on my pink calculator so that way you guys can see how I do it. When I do 3/2 times -2, I get -3. So I get 3/2 y minus 3 equals, and then those two are going to cancel out, and I'm just left with x. So there's x by itself. Next step, switch your x's to y's and your y's to x's. That's the part where it officially becomes an inverse. All right, last step, go ahead and use the new notation, which we already have written there. I just need to fill in 3/2 x minus 3 is my equation. So to graph this one, I'm going to do it the same way I did this one. I'm going to start at -3, and then I'm going to do my 3/2 is my rise over run. Now, remember what I said up here about if they're going to intersect, they're going to intersect on that line. Well, this one has a point right here on that line, so I have a feeling they're going to intersect there. So let's see, up 3/2, up 3/2, and if I happen to go up 3/2 again, it does cross at that point. So when I draw that line in, again, draw it the whole length of that graph, the whole, from edge to edge, so that way you can see it clearly, okay? So those two go very much together, 3 points here and 4 points there, okay? If you would prefer to make an XY chart, I know some of the teachers would prefer that you do an XY chart as opposed to the rise over run method. That's fine. Just remember that on your inverse, you can just flip your X's and Y's like you did up here to get the inverse values, okay? Now, this one is exactly the same as number 3, except I don't have to graph it. I just have to find the inverse. So a little bit more practice with finding the inverse. So I'm going to start with changing f of x to y equals -2x plus 4. Now I got to get x by itself, so I'm going to subtract 4. That gives me y minus 4 equals -2x. And then the last thing I have to do is divide by -2, and over here I need to divide each part by -2. This is going to become -1/2 y. -4 over -2 is going to become +2, and then those two are going to cancel, leaving me with x. Okay, next step, I take this guy and I change all the x's to y's and the y's to x's. And now I can put it back on my line here with the new notation, -1/2 x plus 2. All right. Now, just to answer a quick question, because I know it comes up sometimes. Up here, well, let me step back for a minute. Here I just needed to divide by something to get the x by itself. Up here I had to multiply by the reciprocal. Quick reminder, if your number or your coefficient there is negative, your reciprocal is also negative. So if this said -2/3, I would be multiplying by -3/2. That way a negative times a negative gives me that +1 coefficient. So the reciprocal is the exact same sign as the original. If you have a negative there, make sure to keep that in mind. Okay? All right, 6 and 7 go together. We have a parent function, which is graphed for me, and I have a transformed function. Okay? So I'm going to start off with the description. What do I know about this graph? And I like bullet pointing it because it makes it easy for your teacher to grade, and you always want a happy teacher when you're grading, don't you? I'd rather have a happy teacher grading my test than a irritated teacher or a frustrated teacher. So I see a -1/3 in front. That has 2 components to it. The negative means I have a vertical reflection. And the 1/3 means I have a vertical compression. Now you can't just say stretch or compression. I want to know what that scale factor is. So vertical compression of 1/3. So this statement here, the reflection takes care of the negative, and the vertical compression of 1/3 takes care of the 1/3. Next, I need to deal with this guy right here. There is no K value out here, so I don't need to worry about this, but this tells me there's an H value of -1. That means I have a shift to the left 1. Okay, so 3 little bullet points there. All right, so now I'm going to go ahead and graph this over here, and then I'll fill out domain and range. So what is my vertex for this? Well, it's going to be HK. All the important points are always HK, aren't they? So if H is -1 and K is 0, my vertex is -1, comma 0. -1, 0. So -1, 0 is right there. Should I go back to pink? Is it easier to see? And I'll go back to pink on the other side. All right, from there I talk about the slope on the right. The slope on the right is -1/3. Go ahead and put the negative with the top number. It's just easiest if you do that. You can put it with the bottom if you want, but it gets a little trickier to graph. So I'm going to rise in a negative direction, which means it's going to go down. And then I'm going to go run in the positive direction. So I'm going to go down 1, and then right 3, down 1, right 3. And then what do I do to get the other half of my graph? I go back to the vertex. I still go down 1. I just go the other way 3 to get that mirror image of what's going on over here. So again, down 1 over 3, and hopefully you'll be able to fit 2 points on each side. So again, go the entire width of your graph if you can. But just make sure not to go through that vertex, because that vertex does need to be a point. It needs to be a corner of sorts. Okay, so my domain, I've got arrows going out, which means left to right. There's no boundaries, so I have all real numbers. My range, the highest value, it looks like it only goes up to the axis right here, to the x-axis, which means all of my y values are less than or equal to 0. There is not a single part of that graph that goes above 0. And then over here on my end behavior, both ends are going down, so I need to put both ends going towards -infinity. Okay, so again, those two go right together. All right, so on this front side was a grand total of 25 of your 50 points. So on the back side is going to be the other 25. All right, so use the parent function, f of x equals the cube root of x, and the transformation to talk about the transformed function and graph the transformed function. So just like I did with the other one, I'm going to start off with the description. I have an a value. It's not negative, so I do not have a vertical reflection going on. It is, however, a number, 1/2, and because it's a 1/2, that means I have a vertical what? Compression. And again, give me that scale factor, a vertical compression of 1/2. Now, if that was a 2, not a 1/2, I wouldn't have a compression. I would have a vertical stretch of 2. Make sure you're always giving me that value with it also. Okay. In here, I have an H value of +1, and I have a K value of +5. Change the sign of your H value. Don't do it to K. So let's see. That means I have a shift +H, so right 1, and this one is a shift up 5 for my K value. All right. One thing I do know about my domain and range for this guy, before I even graph it, is since it's a cubic, it's going to look like this. It's going to have a domain and range both of all real numbers. So if I remember that, I can go ahead and fill that in. All right, so how do I do my XY chart? Well, HK always goes in the middle, 1, 5. And then if we remember from our cube roots, what are the nice cube numbers? 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and so on and so forth. So from here, I'm going to go 1 away in each direction. So 0 and 2, because that's 1 away from 1, and that's 1 away from 1. And then I'm going to go 8 away. So what's 8 away from 1? Well, it's -7 that way. This way, 1 plus 8 would be 9. And as long as I use those numbers, I'm not going to go 27 away, obviously. That's just going to be ridiculous. But as long as I stick with those numbers, I should end up with values that are nice numbers. Now, since there is a 1/2, I might end up with a 0.5, but I shouldn't be getting anything too much crazier than that. So let me plug in -7, so I have 0.5. You can use 0.5 or you can use the fraction button, doesn't matter. And then cube root. How do I do it cube root? Well, let me go ahead and put my 1/2 in parentheses, just so it doesn't get mixed up with the cube root. I'm going to press a 3, second, and then my exponent button. And it should say 3x radical. That means I'm taking a cube root. I'm going to open some parentheses, plug in -7, -1. I'm going to close my parentheses so that my calculator knows I'm done with my h value, and the next thing that I plug in is going to be my k value, which is not under the radical. Now I only have to be careful about plugging that in once, because then you can just arrow back and change what you're plugging in. So there's my 4. Like I said, that was going to be a nice number. Now I'm going to go back and I'm going to change the -7 to a 0. So I'm going to arrow back. I'm going to change the -7 to 0. Now if I put a 0 there, do you see how it says -0? That doesn't make sense. So I'm going to go till my negative sign is flashing, and I'm just going to press the delete button once, and it should take out that negative sign for me. And I get 4.5. Uh-oh, I don't want 4.5. I want a decimal, because graphing with a decimal is a lot easier. So I'm going to hit second, get my fraction and decimal button, and that's 4.5. Now, oh shoot, I just lost the whole equation that I typed in. Well, I didn't, because I haven't hit clear at all. So I'm just going to press the up button, and if I hit it up twice, there's my equation still sitting there. So I'm going to go change that 0 to a 2. I get 5.5, so let's change that to a decimal, which is 5.5. And again, if I arrow up, there's my equation again. Now change the 2 to a 9, and we get a nice value. So again, if you have any questions about how to use your calculator for that, make sure you ask them before test time. All right, -7, 4, 0, 4.5, 1, 5, 2, 5.5. Those are really tight in there. And then 9, 6. So this is a really skinny, not the prettiest drawing, but that's a really, really skinny cube root function right there. Okay, you will get some points for showing your table right here, as well as some points for the actual graph of it. Okay, remember with the cube root, you're always going to have those 3 points in the middle that are all grouped together, the very middle one being your point of inflection, and then 2 points out here to kind of show you how wide your graph is, or in this case, how tall your graph ends up going. Okay? All right, so there's my cube root one. Now I have a square root graph. So here's the parent function of a square root graph. That's just the square root of x. And I have to graph this one. So again, I'm going to start off with the description. I have an a value of 2. It's not negative, so I do not have a vertical reflection. I just have a vertical stretch. And why is it a stretch and not a compression? Because that number is bigger than 1. So I have a vertical stretch of 2. Make sure you're giving me that factor in there. Now, this negative sign in front of the x, that means I have a negative b value. A negative b value means I have a horizontal reflection. Now, thankfully, doesn't have to be too confusing. I don't have an h value to deal with. So h is just 0. I don't need to mention that in my description. I do have a k value, though, because this minus 1, do you see where the square root sign ends? This minus 1 is outside of the square root. So my k value is -1, which means I have a shift down 1. Okay, not going to fill in domain and range. I find it easier to look at the graph. So let's see. Let's put our hk in the middle. That would be 0, -1. Now remember how I got my numbers. My cube numbers I used for cube roots. I'm going to use square numbers now. 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on and so forth. I'm only going to use 1 and 4. We don't need to go to 9. So I'm going to do 1 away from 0. Well, that would be -1 on one side and +1 on the other side. And then 4 away from 0 would be -4 and +4. Okay? Now remember, with a square root, one of these sides, either the -4 and the -1 or the +1 and the +4, is going to give you imaginary values. You're only going to get 3 values that work out on your XY chart. You're going to get your HK value, and then either this side or this side. That's because our graph only goes one direction. So, let me plug this one in. I have 2 square root of negative, notice it opened parentheses for me. I'm also going to open parentheses for the -4 I'm plugging in. So if I have 2 parentheses open, I need 2 parentheses closed before I put my -1. So let's see if we get a value for -4. I do. Good. Now I'm going to go change the -4 to a -1, and I get 1. Let me show you what happens on the other side. I'm going to change that -1 to a +1, so I'm going to highlight the negative and delete it. See how it says error? That's because that answer gives me an imaginary result. If I go and I change that to a 4, same story. I get an imaginary result. So like I said, only one side is going to give you values. So let's plot these points. -4, +3, -1, 1, and 0, -1. Now, I have to check, am I going from this point down, or am I going from this point up? Well, which one was my HK? 0, -1 was my HK, which means that has to be my starting point, and I'm going that way. So that's what my graph looks like. So let's talk domain. Left to right. The furthest point to the right on this graph is at 0. I can get that from my h value. So all of my domain, all of my x values are less than or equal to 0, meaning they are to the left of 0. All of my y values, they have a lowest point, so they are all greater than or equal to the lowest point. And it looks like the lowest point is my k value, which is -1. So h is always going to be related to your domain, and k is always going to be related to your range. Now let's talk end behavior. As x approaches infinity, that's asking about the right side of my graph. I can see the right side of my graph. I don't need to talk about where it's going. It's not going anywhere. It's stopping right there. So the right side of my graph is the side that I'm going to cross off. Sometimes it might be the left side, sometimes it might be the right side, but with square roots, you're going to cross off one of those two sides. Then we can talk about the left side. The left side, yes, it's going to the left, but it's also going up slowly. So I'm going to say it's going towards positive infinity on the left side. Okay. These two, I believe, were 10.2 is on square roots and 10.3, I believe, is on cube roots. So feel free to go back and look at those lessons for more information there. Okay, I have one more cube root and one more square root, and what I have to do is write an equation. I'm going to switch to my pink pen now. Okay, so the first thing we do on any of these is we identify what h and k is. All right, if you notice in this equation right here, there's a, h, and k. There's not even a b value in there. See, no b value? Yay, which means I don't need to worry about a b value. So, first off, because this is labeled, f of x is my parent function, g of x is the translated one. The first thing I notice is that my end behavior on g of x is going opposite of the end behavior on f of x. In other words, if I was my little stick figure, I think I did this earlier a couple days, and I was walking along the parent function, I might have a little wiggle in the middle here, but eventually I'm going uphill. That's not the case for my transformation. My transformation, my little person, is not going uphill, they are going downhill, which means we have a reflection going on. Since there is no b value, that reflection has to go with the a value. So I'm going to put a negative at the very beginning because I know my a value needs to be negative. My inflection point, where's my inflection point? Well, let's go find those 3 points in the middle, right, where it kind of flattens out right there. That's my inflection point. And the coordinates of that looks like it's what? -4, -2. There's my h, and there's my k. All right. Let's see. So I'm going to have a cube root in here. I'm going to have x. This is a -4, so it's going to look like a +4. And then make sure your square root symbol stops and does not go over any part of the k there as well. All right, last thing I need my a value. Now, if you remember, I showed you this box thing where on your parent function, your box is always 1 by 1. Always, always, always. On your transformed one, you can go either from your point of inflection to the left or your point of inflection to the right and make your box with the very next point over there. And this box here is not a 1 by 1 box. It is a 1 by 3 box, which means what about my a value? It's 3. Okay? One quick thing I want to mention there, because if you happen to get your letters in a different, say you get your a value first and then you do h and k later, be very careful between this and this. And this is more of a notation issue, but I see it very, very often. Right here, it's a little bit unclear to me whether that's -3 cubed times the square root of x plus 4, or if it's -3 times the cube root. I don't really know if it's a square root or cube root, and sometimes people bump that -3 out and it gets even more confusing. Really try and tuck that 3 into the root, into the radical. That way I know that you know what you're talking about, that it's not an exponent on the number out front, but it's actually telling me what kind of radical it is, that it's not a square root. Okay, so just something to be aware of there. And right now, cube roots are the only place where it's an issue. Okay, there'll be an issue again later, but not right now. It's only with cube roots. All right, so this one I have a square root. We have it labeled. F of x is my original parent function. G of x is the transformed one. Now this one has an a, b, an h, and a k. So the first thing I want to do is I want to look here. There's the arrow point, which means this is my vertex. And the coordinates of that point are 2, 4. That's my h value and my k value. So I know that as I'm filling this in, I'm going to have x minus 2 plus 4. All right, now let's talk about any kinds of reflections. This one, it starts here and goes up and to the right. This one doesn't go up, it goes down and to the right. So they're both going to the right, which means horizontally I'm not seeing a change. It would be a change if one of them was going to the right and one of them was going to the left. Horizontally, they're both going the same way. But because the original was going up and the transformed one is going down, I have a negative a value because I have a vertical reflection. Now let's look at what that a value might be. Again, your parent function is always a 1 by 1 square. If I look at this one also looks like it is a 1 by 1 square. What does that tell me? That tells me I have a vertical reflection only. I do not have a stretch or compression. So that means a is -1. So I'm going to put all this in there. I have a -1. I don't need to write the 1. But I have a negative square root of x minus, because it looks like a plus there, I've got to change it to the -2. And then my +4 needs to be out there. Okay? Now, just to address something that may come up, if you have a b value that's -1, make sure that when you plug in your b value of -1, you still have your x minus h in parentheses. Don't distribute that b value or anything. Don't worry about how that sign changes. Just put a negative and then parentheses, and then treat the h just like you do up here. That's if you have a horizontal reflection, which we don't here. Okay, so I'm going to cross that off just because it doesn't apply to this. I want to make sure that if anyone's taking a picture, they've got it straight. Okay, happy studying.